I'm actually here with Matt Rock, and you work for Chef, is that
Yes,
right?
I do. That's
I
right.
went to a Chef Conf, probably not this one that just happened, but the one before in Austin, and I remember that there was a new thing called Habitat, and I'll tell you just a short story, because I know your demo is good. There was a hat that they gave out, and mine was too small. And in the spirit of open source, I went into a cab with this dude, and he said, well, Seth, my hat is too large. And so we swapped in the spirit of a cooperation. But during that whole time, I feel like I didn't really understand what Habitat was, even though I had the sweet hat, which I still wear when I do garden work. So why don't you help us out, my friend?
So what did you swap it with? So you had a Habitat.
I had a smaller hat, and he had a larger Habitat hat. And so we swapped it, right? And so it was a very special moment, and after that we hugged for a while. It was awkward for him.
That's nice. Yeah, that's
So
great.
tell us about Habitat, because I felt like it was a container, but it wasn't. But it was more like an environment, but not that. I feel like it's a very, like things that I don't understand quite yet, I feel like they're super powerful if I just understand a little bit more. So Matt Rock is going to help us out a little bit by showing us how to modernize our Java development workflow with Habitat. Take it away, my friend.
Yeah. So hopefully I can fill in some of those gaps for you. So yeah, what we're going to do today is I'm going to show you. I'm going to basically give you a tour and go kind of through the Habitat ecosystem and show you how we're going to modernize kind of your everyday development workflow, deployment workflow using Habitat. So real quick before I kind of dive in. So my intent today is to give you that overview, to kind of give you that guided tour and show you what that workflow is like. But I'm not going to necessarily dive into all of the nooks and crannies of Habitat, which there are many. And so if you're watching this, or if anybody out there is watching this, God, I hope people out there are watching this. But
well, my mom is on for sure.
Yeah. So if you have questions, or I mean, there are we have Gitter and Twitter and all that stuff. But things, if you light bulbs pop up in your head, and you want to dive more into the details, so at www.habitat.sh, we've got all sorts of documentation. We have tutorials that you can go through. We also have a Slack channel, so that's a great place to go if you want real-time answers to your questions, and that is heavily watched by actual Habitat core maintainers, so good chance you'll get a timely response there. Everything I'm going to show here today is on GitHub. We've heard about that, and most of us know about that. It's in my org, mrock. The name of the repo is national-parks. So Automate, as you mentioned, it's brought to you by Chef. And we're not going to talk a whole lot about the actual Chef client today, but I do want to mention that we now have a presence on the Azure Marketplace. So if you want to check out Chef, if you want to set up automatic deployment of your infrastructure, of your nodes on Azure, totally check out tinyurl.com/automate Azure, and you'll get all sorts of information about that. So that's about all I'm going to say about Chef. A lot of people know about Chef. They know that Chef is a great tool for automating your infrastructure. The thing that really differentiates Habitat from Chef is where Chef, the center of automation is the servers, the node. We're known as the people that kind of take your server from nothing to what you want it to be. Habitat focuses on the application. So what Habitat is about is providing an environment, a habitat, if you will, for building your application, packaging your application, deploying that package to a centralized repository, and then having what we call Habitat supervisors. So these are your application servers that are actually running your application, consume that depot, and run your application. So we go all the way from building your application to monitoring your application. So it's a Habitat for that whole application lifecycle. And so I'm sure there's a lot of questions there.
Yeah.
And what we're going to do is we're just going to do it.
Let's do it.
Yeah, so...
and if you saw me awkwardly pointing everybody, that's because that's your camera over there.
Oh, okay.
So look at that one, because then people are like, you're not looking at me.
Okay, I'm sorry.
So everyone that saw me awkwardly point, welcome to my life. Okay. Go ahead, buddy.
All right, man. So first thing we're going to do, we're going to build a Java application. It's a fairly straightforward application. It's a web app. This is going to be running on Tomcat. So a lot of Java developers should be fairly familiar with this kind of an application. And so we're going to have Habitat build this for us. And the thing that we need to do to make that happen is create a plan. So a plan is going to tell Habitat about our application, and it's going to tell Habitat how to build our application. So our plan, as you can see here in my editor, is called plan.sh. It's going to be either plan.sh, as it is here if we're targeting Linux. It could be plan.ps1 if we were on Windows. It would be PowerShell.
Right.
But the fact of the matter is, a plan is shell script. So you don't have to learn another language. The chances are, if you're a developer, you know shell script. So you should be comfortable in this environment. And the plan has is usually comprised of two major sections. One is metadata, so the section at the top that basically it describes your application, and then the part at the bottom, which is essentially callbacks that you're going to implement to tell Habitat how to build your application. So if you look at some of these things at the top, we've got some basic stuff. So like name. Our application is called National-Parks. We're going to display all the national parks in the United States. Awesome. We have an origin, so you can think of this as a root of ownership. It's kind of like a GitHub organization. This is my personal origin, MRock, but this may very well be your company name. Mm-hmm. We've got version, we've got dependencies. So this is a big part of Habitat, is managing your dependencies. So and what Habitat allows us to do is to split up our runtime dependencies from our build time dependencies. Because like a lot of us know, as developers, there's tools that we need to build our app, but then we'll never need those tools again. We're going to use Maven here to build our WAR file, but we're not going to need, there's no need for our application servers to pull down Maven. Our application servers will absolutely need Tomcat. Mm-hmm. So that's one of our runtime dependencies. And then we have bindings. So bindings is an important concept in Habitat. I'm not going to go into all the nuts and bolts of syntax around bindings, but suffice it to say, so bindings is how services can talk and connect to one another. This is a powerful concept in Habitat. So as I mentioned, in Habitat, we have supervisors that run your application. And so a supervisor is basically a process that starts up your application and runs on a server. It can run on a container, it can run on a VM, it can run on bare metal, it doesn't matter. But the fact of the matter is, today in our in distributed application land where we all live, I live there, I think. You live there?
I write demoware, and I've been writing demoware for the last 7 years. It's really sad. So I'm really excited. The thing I'm liking about this, as you're asking this, is that this feels a lot more than containers. Containers is an output of a process. This is more a description of both a pre and a post process.
Absolutely, and this is as we're going to see later in the demo, this is going to set us up really great for containers. So what I'm getting at with the binding is that in a distributed application, the application is not the application itself. If we were to just build this application, we would be very disappointed. I couldn't call it national parks because there would be no national parks. There would be no parks because we need a database. We need something. So we're going to need to bind to a database service. Furthermore, this application is going to take off like wildfire because, national parks.
Yeah.
But so I'm expecting a lot of traffic, and I can't just run this on one node. So I'm going to have a few nodes in Azure running this application. So I'm going to need a load balancer, another service. So we're going to be using HA proxy, and HA proxy is going to need to be able to bind to us to be able to load us into its configuration, so it can be my front endpoint to hit, and then it'll fan out to my application servers. So all that is going to work together in Habitat, and we'll see how that works. And that's what bindings provide. Bindings provide a way for supervisors to expose configuration data about the services that they're running so that those services can discover one another and connect and interact with one another.
Got it.
So now we'll skip down to the callbacks. Again, there's a variety of callbacks that you can implement. This is a fairly straightforward one. We're only implementing a few. But suffice it to say that this is going to tell Habitat how to build your application. Habitat is basically technology agnostic. So there, Habitat was written in Rust, but it can build any kind of application. But it doesn't know anything about Java. It doesn't know anything about Ruby, about Node, about C#. But we know about that. The developer of this application you certainly know how to build your own application. So this is your opportunity, an opportunity which I suggest you take, because otherwise not a whole lot's going to happen. That to tell Habitat how to build this. So we can see, for example, here when we do in the do build, we're going to call MVN package, and because I've declared Maven as a build time dependency, I know that Maven's going to be on my path, and I can use that tool to package up my war file. So when Habitat is all done with this plan file, what it will do is it will drop what we call a heart file, an immutable artifact, our package that contains all the artifacts, in our case a war file, that your application needs to run. So this is a war file. If it was this a C# app, it might be your DLLs, your exes. If it was Ruby, it would be your gems. So all that, all those raw artifacts, plus the descriptive information. For example, it's going to have your dependencies and their dependencies, the exact versions that you built against, which is important because what that means is that when I build this application, so we trust that all of my dependencies are Habitat packages as well. And Habitat will allow us to basically dynamically link against all of those libraries inside of the Habitat environment. And so what that means is what we build with is what we run with, and that's super important.
Well, it's also frustrating, right? Because how am I going to say it worked on my machine?
Exactly. Yeah, that's the quintessential scenario right there that we try to.
Yeah, I'm not going to be able to get out of it not working. Is that what you're saying, Matt? I hear you now, buddy.
So let's actually do it. Let's build this application. So there's a couple ways that we could build the application. One way, what we're going to do today, is to build it actually locally. What we could do, so a couple weeks ago we launched a new service called Builder. It's basically a hosted build service where we can actually watch your GitHub repo. We can watch pushes coming into your GitHub repo. So as your application changes, we can actually build your application for you. We can take your application, package it up. We'll upload those packages to a depot where your supervisors can automatically consume those packages. So it fits great into your CI/CD solution. But what we're going to do is we're going to just build it right here, because this is what I'm trying to lead you through here is the developer workflow. And so we're developing this application version 6.2. So let's build this. And real quick, so a little word about this environment that I'm in over here. So this over here, this is what we call the Habitat Studio. And this is a special environment, so depending on what platform you're on, so I'm on Windows, but it'd be the same if you were on a Mac. When you enter a studio, we basically spin up a Docker container that includes in it a very small Linux distro, very minimal, that has a running Habitat supervisor and Habitat build system. So this is where I can test building my application and then I'll be able to actually test running the application. And what's key is you can think of this as a clean room. So as I mentioned, the Linux distro is super small. So there is a very small path, very little in your user bin. So the idea is that any dependencies and any tools that I need access to are going to be exposed to me as actual Habitat packages. And again, that enforces the guarantee that what I build with is going to be what I run with. I don't have to risk building this and having it linked to some other glibc off in the distance, and then I port this to my live environment, and I get the spontaneous combustion effect.
And we can spare ourselves the embarrassment of it, like crashing a build or something, because you can run it in a clean room environment on your local machine. And everybody knows after 6 months, your machine is like, you've installed too many things and things get weird. And so having like this really cool local clean environment is pretty powerful.
Oh, totally. Yeah. So let's do it. So I'm going to type build Habitat. And what this is going to do, this is going to look for a file called plan.sh. inside the Habitat folder. And so when I entered into this studio, it mounted the directory that I entered the studio from into this source directory in the container. So what that means is this directory over here in my editor is mounted over in the container. And so what's cool about that is if I made a mistake here or if things change, I want to change stuff, I can change things over here and they'll be automatically manifested over here. So
and these builds are happening, when it says installing JDK or whatever, it's installing it on that container.
Exactly, that's correct, right. So we saw the Maven output, and okay, so it's finished. So now we have a heart file, our artifact. It drops that in the results folder. So let's take a look at that. Lots of builds. I've done this quite a few times. This is the one we're interested in, 6.2. I'm going to just copy that.
Yeah, that's the one I was going to say looked good.
Oh yeah, it's gonna be so much better than 6.1.
I know, that's a good one.
6.1. So at any rate, so now what we're gonna do is we're gonna run this locally. Let's see how this all worked out. So we do have a running supervisor here. Let's see what that supervisor is doing. Let's type habsup status. What you up to, supervisor?
I thought it was like sup, what's up?
What's up?
Hab? I feel like that's what you should have gone with.
Yeah, that's strategic thing. But so I do have this tells me I do have a service running. I have my MongoDB service currently running in the supervisor. That alone isn't going to do a whole lot for me. So let me go ahead and start the application I just built. So not only does it drop this heart file, but it also installs the heart file, installs the package into the local Habitat environment. And what that means is I can do this, so I can say hab start, hey Habitat, start my application, mroc/national parks, and it passes this bind argument. So this bind speaks again to the binding we talked about earlier. It's going to say, we're saying, hey, that database binding we talked about in our plan that is expecting to have a port property exposed to it. Well, you can find this right here is saying, well, you can find something that fulfills that contract in this service, this np-mongodb service, which is the service that's running. So I'm going to hit enter, and I don't get a whole lot back. It basically says, thank you very much, supervisor started your application. If I wanted to see more, I can type soup-log, which is essentially going to follow the tail of the supervisor log. Sup log?
Yeah, that's right.
And so I see some Java-y, Tomcat-y stuff. I know things are happening, but let's absolutely make sure things are happening. So this is the glory that is the National Parks application. This isn't running on Azure, actually. So this is my HA proxy endpoint. So let's change this to localhost and see if 6.2 comes up.
Just to keep us honest.
That's right. And there we go. So 6.2, I have national parks, which is great. So the system works. So that's the develop workflow. So now let's say, hey, my development workflow looks great on my machine. Let's push this off to Azure. So here is my Azure portal, but the VMs that I have in Azure. I've got 3 application servers. So these 3 servers have 1, 2, and 3 are running Tomcat.
Those are good names.
I thought so. Yeah, thanks. HabMongo, that is running a supervisor that's hosting my database. And HabHA is another supervisor, another VM with a supervisor running HA proxy that's load balancing Hab 1, 2, and 3. So port 8080, which is what Tomcat runs on, is not exposed. I can't hit that on 1, 2, and 3, but I can hit that here on my HA proxy, which is load balancing these guys. So if I go over here, let's go back, and I'm going to refresh just to make sure it really is running 6.1. So this is old 6.1. This
the good one.
No.
We decided.
So what we want to do is we want to. I have Hab 1, 2, and 3 specially configured with what we call an update strategy. And that update strategy is called rolling. And what that means is these 3 nodes, these Hab 1, 2, and 3, have elected amongst themselves what we call an update leader. And so that update leader is right now watching the Habitat depot and looking for updated packages.
Which is those heart files.
Exactly,
Got it.
Right. So if that update leader sees an updated package, what that leader is going to do is it's going to have each of its followers, one by one, update themselves, and then it will update itself. And so the power of that is that we can in real time update our application node by node, and not all at the same time, because if they all update themselves at the same time, they all go down at the same time.
Chaos and
outage,
cats and dogs living together.
So this is going to be a no tiers deployment, so let's do this. So the first thing we need to do is actually upload our heart file, and because I put it in my clipboard, I can just paste it in. So I'm going to delete that.
Yeah, we want the good one.
Totally. Okay. So it's uploaded to the depot, and now let's actually look over here. So here I have, so these three guys, bam, 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 are Hab 1, 2, and 3. And so they're actually watching the depot once a minute. So really it's going to depend on
So should we just like awkwardly stare at each other for a minute?
Right.
I think that'd make for good television.
Look into our
look
search our
deeply
hearts.
into my eyes.
So there we go. Okay, so updates are happening.
I was
So we're
hoping
moving.
at one
And once all these guys are done moving, I'm going to expect to see 6.2. So let's queue that up. Over here, so I'm going to hit the refresh.
And again, this is hitting the load balancer. Look at that.
That's right. Yeah. So I'm hitting the load balancer. So the load balancer is balancing those three nodes, and 6.2. Yeah. This is so much better, right?
I feel like they are better. Yeah.
Yeah. So awesome. So now in the real world, typically you're not going to be deploying from your laptop to production.
We shouldn't.
Yeah, we should.
But some people live on the edge.
That's true. Yeah. I've been guilty of that. But at any rate, this is a perfect world that we're living in right here. And so what we can do, we can pretend that these were actually my staging nodes. Mm-hmm. We in Habitat we have this concept of channels. And so we have an unstable channel and we could have a stable channel. So right now I actually have these nodes specially configured to watch the unstable channel, which is where things go when you first push them to the depot. But if I felt good about this, I could run a single command that basically just promotes them to the stable channel, and then my production servers would be watching that channel, which is what they watch by default. So that's great. I see my stuff in Azure. So now let's talk containerization. We're probably running low on time.
No, we got 5 minutes. Man.
Okay, awesome. Well, the beauty is that there's actually not a whole lot to say because Habitat has already set us up great for containerization. Because
so we will have time to stare at each other.
Yeah. Oh, I've made time.
Yeah, we've made time.
Yeah, that's definitely been a goal today.
Cool.
So because in Habitat we have this great kind of isolated environment, with portability, it makes it easy for us to convert our application over to a container. And so Habitat makes that super easy. There's really just, with a single command called export, I can export any package and export it to a variety of different formats, one of which is a Docker image. And so what happens when we do that is basically it starts up basically a bottom layer, again, that small Linux distribution that we saw in the studio, super small, and then it adds to that the Habitat supervisor. So I've got all the Habitat stuff that I need to run Habitat and anything in Habitat. And then it takes my package along with all of its dependencies and all of their dependencies. So the entire dependency tree takes all of those packages and adds that to the image. So in the end, I have this image that can run, that has everything it needs to run. And so if we go back to Azure, so this guy down here, this bottom right-hand one, this is a Docker host that I have running in Azure. And let's do a Docker PS, see what's going on. Probably the last time, same thing that happened the last time I hit Docker PS. So it's running a container, a single container, my MongoDB. So I exported my MongoDB package, but again, that container is not going to do me a whole lot. So let's start up our national parks container, which I've previously, it's like a cooking show,
Yeah, of course.
I previously create an image out of that. And let me also, just to back up real quick, what's cool is, so that builder service I mentioned, not only will it build your stuff for you, not only will it upload the heart files to the depot, but you can also configure it to then export your package to a Docker image and upload that to your Docker Hub registry.
We literally don't have to work
cool.
anymore, it feels like. This
right,
is
yeah,
just
exactly.
amazing.
Yeah, the robots have won. So at any rate, so here, if you're familiar with Docker, you're probably familiar with Docker run. So no magic here. I'm forwarding port 8080, which is what Tomcat's running on. My image name is basically the same as my application name, National Parks. And then all the other arguments are just forwarded on to the supervisor that's going to be running inside of that container. We've already seen the bind argument, so I won't really cover that. But the peer, so this is how supervisors talk to other supervisors. So we saw locally inside that studio environment, we saw two services, but they were running inside the same supervisor. So we didn't need this peer parameter. But you could conceivably have what we call a ring of supervisors. So when you have supervisors that are connected to one another, that's called a ring. And there could be hundreds, thousands of supervisors.
We call it overhead here at Microsoft. That's a joke. That's a joke. Sorry, boss. Go ahead. I'm sorry. We had an extra 20 seconds. I wanted to.
Yeah. Glad we got that. So it's good stuff. So so you could have all these supervisors running in this ring. So somehow I am nothing. But I want to start up a supervisor. I want to join that ring. All I need to do is give it the IP address or host name of one member, one peer of that ring, and then it'll start gossiping among that ring and join that ring. Now, in this case, I only have one peer, so it's going to be pretty easy which IP address I choose. 172.17.02, that is, I just so happen to know, because I know these things.
Sure.
But, that's what the MongoDB container is running as. So if I'm going to run this, so what this is going to do, so now this supervisor is starting up, and we see some Tomcat action going on with our war file. And so now, let's go over to this other tab. So it was broken. So this is now I'm hitting my Docker host. Now this is 5.6.
Yeah,
this is like
it's the ugly one.
Yeah. But like I said, that builder, our builder service can automatically upload. So if I were to push this to GitHub, we would see the builder service actually start to kick in and build this. Then I could just do a Docker pull and I could get 6.2.
So I'm starting to understand now, because Habitat not only describes your application in terms of what it needs, it also describes your application in terms of how it runs and how it builds. Aside from that, the output of that is this heart file, which I'm assuming is a Habitat runtime file, that tells you all about not only what you're running, but how you're running it. And because it's so self-contained, you can take that and put it into a Docker container or put it into some other whiz-bang G, which is going to come out sometime next week.
Exactly, yeah. It's very, you can put a container, a VM. I mean, you could have supervisors running Windows, supervisors running Linux, talking to one another. Pretty soon you've got cats and dogs living together, and it just gets crazy. But
you know what? I mean, this is amazing, Matt. This is really cool. I feel like I'm starting to understand Habitat a little bit better, and it's because it feels like containerization, while it is something that can be part of Habitat, it's definitely not the entire story. Yep. Where can people go to find out more about this before we close up? Yeah, so as I mentioned earlier, and here's the slide again, so habitat.sh, that's going to have all of our documentation. It's going to have tutorials. It's going to have a link to that builder service that I mentioned before, which is totally free. I want to make sure I got that out there. Then Slack is very active. So if you have questions you want to ask in real time, if you're hitting a wall, if something doesn't make sense or something just seems broken, it's a good chance, well, not a good chance, there's a chance that it is broken. And there are people standing by that that can fix it. So it wouldn't be the first time that somebody's reported a bug there, but we can get stuff fixed very quickly. But more importantly, we can communicate concepts and get you on the right track. And that's the place to go. Well, thanks so much, Matt. This has been very instructive. We've been learning about Habitat, how to modernize your workflow. We had a Java app, but as you can see, this is agnostic to types of applications, even
absolutely.
dependency, even everything. Thanks so much for spending some time with us.
A pleasure.
We're going to give you a little bit of a hand, and we're going to toss it over to Ashley.
Thanks so much.